Thank you. Yeah, so I'm Brian Knauss. I'm presenting here with Kim Curtis, and we're from eBay. We work in the Data Services and Solutions organization. I lead architecture, and Kim leads engineering in our Seattle area office. And we're here to talk about the evolution of our enterprise data ecosystem, and specifically how we inserted Spark into that very recently. I'm going to talk about sort of the mechanism we went through, the process we went through to decide on injecting Spark, and then Kim's going to talk a little bit about the specifics of what we did. So when we look at sort of guided evolution of a technology stack or framework, I think of this in terms of three phases. One is you have some principles. There's some guiding principles you use for determining how you want your technology stack to evolve. And that informs then the opportunities that you identify. And those opportunities may come from problems you encounter in the system. It may come from new use cases. It may come from attending a conference and getting excited about a specific new capability that exists out there. But those opportunities are going to be evaluated within the context of what your principles are to sort of prioritize them. And then they're going to be evaluated against the cost to implement, the pool of resources you have to draw from, and the priority in order to determine which of these opportunities you're going to choose to invest in. And so the principles eBay uses currently, and these things evolve over time, is specific to our enterprise data ecosystem is sort of threefold, and these are in priority order. One, we want to expand capabilities. We never want somebody to come to the enterprise data ecosystem and not be able to do something, because likely what that means they're going to go off and build it themselves in some splinter somewhere, and we're going to run into challenges longer term governing that. We want to increase flexibility. So if we're very structured in how we allow people to interface with the environment, again, they may find something else they want to do and they go implement it in a slightly different way, and we lose control over how that data is being propagated. And last, we want to make sure that we're maintaining cost performance, right? We don't want to necessarily expand our capabilities too much at the cost of the overall platform operation. So really, we simplify this. It's do more with fewer barriers, cheaper, faster. And an anecdote I would use in this space is a number of years ago, there was a data consumer operating on one of our platforms accessing our behavioral data, which is sort of the weblog data, very voluminous data set. And they came to me once and they said, I need capacity on this platform because I've discovered this data insight that allows me to save $1 million a year for the company. I mean, this is a great idea, but knowing that this was a relatively cumbersome set of workload, I did the math and figured out it was probably going to cost over $2 million a year to operate the systems to run that workload. So hey, this is not a good business decision. We're spending $2 million to save $1 million, but that wasn't the fault of the person who came up with this insight, right? This is exactly what we want people to do, using the data within the ecosystem to identify business costs. It was really a failure of the platform itself to provide a way to do that in a cost-effective manner. Whoops. Okay, so specific to injecting Spark into the data ecosystem, when I talk about our data ecosystem, there's a number of components. Specifically, we have a sort of very mature, robust, vendor-based enterprise data warehouse, sort of traditional RDBMS. We supplement that with a couple of very large Hadoop platforms for more open processing. We have a number of different storage things, Cassandra for caching behind our services layer, Apache Kylin for MoLAP. We have frameworks for real-time and batch processing, real-time data presentation, data services layer. And that's the enterprise data ecosystem. And the specific thing we were looking here was to inject open source specifically into the enterprise data warehouse space. And the goal here, what we felt, how this would address our principles was increased flexibility. So our enterprise data warehouse grows at about 20 to 30% year over year. And so when you have sort of a single monolithic vendor solution in that space, you keep writing a check and that check gets bigger and bigger and bigger. And we lose some amount of investment flexibility. The other thing is when you're locked in with a vendor, you tend to evolve. They involve their product based upon their own roadmap and not specifically your roadmap. So you have some challenge adapting in the engineering flexibility space, right? You may lose some opportunity to sort of go at your own pace when you're integrating new capabilities. And so that speaks really into the second part, which is we felt open source injection would allow us to expand capabilities. There's a number of things we could do. Kim will talk a little bit about what we mean here by preload transformation. And then the final piece is really around this cost optimization, which is we want to do this without materially negatively impacting our cost performance. So to dive into the cost a little bit more, this is an interesting space. So often we hear that open source is cheap. But when we talk about what this cost is, this is TCO, or total cost of ownership, or total cost of operation. And there's really 5 factors to total cost of operation. I list 3 here. The first one in this biggest chunk is hardware, meaning if I have a workload, I need to run it somewhere on some type of system somewhere. Now, this may be a capital investment you make as a company, or it may be renting hardware from a public cloud provider. But the biggest chunk is just the physical hardware to execute this. And then the sort of corresponding cost down at the bottom is the data center. I mean, I have to put these servers somewhere, and I have to run power to them so that I can keep the systems operating and keep them cool. And this middle piece is the sort of hardware, software licensing and maintenance. And this is really where we see a material advantage in the open source space, because licensing costs generally tend to be relatively low. But there's a significant burden it has to overcome, in the sense that there's a significant, most of the cost goes really into the hardware thing. And these things you see, they're normalized based upon total cost of a single unit, but it doesn't really tell you how many units of processing you need to run the same workload in each of these cases. Now, I said there were 5. I've only listed 3 here. The other 2 are primarily headcount related, and they're much more subject to political conversations that I try to avoid, and that's specifically around how many administrative resources it take to manage these platforms, right? And then is there a developer efficiency or user efficiency impact, meaning is one of these platforms easier or more difficult for a user? Do I end up spending more time on one because it's more difficult to use? So in order to really align these things relative to the cost, what we have to do is we go identify, in this case for our EDW, we identify a relatively large set of representative workload. And we execute it on each of the platforms, determine the percentage of resources it's consuming, and then multiply that by the cost of those individual resources. And what we ended up with was this chart. So when we first tried to introduce open source, or evaluated the opportunity to introduce open source into our EDW stack, this was sort of vanilla MapReduce HDFS. The cost, the number of processing units it took was significantly higher. And so obviously in 2014, this didn't make a lot of sense. The advantages we were going to get in enhanced capabilities and increased flexibility wasn't really going to offset a 14x cost shift. But then the open source ecosystem continues to evolve. So we see the introduction of Hive, you see the introduction of sort of optimized Hive, and then some purpose-built SQL accelerators like Spark SQL. And what really got us to turn around is around 2017, the introduction of Spark bucketing really changed this cost curve to where we got to about 2 to 1. And the reason that is because our enterprise data warehouse is largely designed to manage the data, partitioned and sorted based upon the most common access path. And with Spark bucketing, we get that now as well in the Spark platform. And so 2 to 1 wasn't quite where we needed to be, but because we've been looking at the entire enterprise data workload, we felt confident, that was an average, so some things were below that 2 to 1 ratio, other things were above. If we were able to focus on just those things where we saw less negative impact, and if we were able to tune the software more, obviously this required us tuning the sample workload we were executing. Maybe we weren't quite as good at Spark SQL as we could have been, and so we had some more opportunity in software tuning. And then we also, actually a big chunk of this came from, we just built special purpose hardware specifically for executing Spark workload. And that got us to where we project about 1 to 1 in 2018. And with continued sort of highly focused optimization, we feel we can actually turn that curve down positive going forward. So at this point, we're ready. We've made the decision to invest, and we head into the investment cycle. And so this is, basically when we choose to invest, we're going to scope the work, we're going to design, we're going to implement, and then optimize, or basically it's the investment cycle. We're going to go determine what we learned and figure out if there's significant opportunities. I simplified this like I did that previous slide. It's not that interesting. What, how, when, and then what do we do? So first, to talk about the scoping. So the first thing we did was we engaged with our customers, 1, to understand what their appetite might be for going with us on this journey, and 2, to anticipate the impact. Basically, based upon our conversations with our customers, they said, yeah, we don't really want to partner with you on this thing. So we said, let's go figure out how we're going to isolate the impact from our customers. So what we did then is we made sure that the workload that we were moving off of the platform, off of the enterprise data warehouse, we were still delivering the results back into the enterprise data warehouse so that the user interface largely didn't change. We wanted to define some boundaries, right? Anytime we go into an effort, you want to make sure you have a sort of achievable goals. In specific, I think it's very important to have goals that, an incremental goal or an intermediate goal that can be achieved and drive value, even if at that point the prioritization on the program shifts. Right, so even if we weren't going to get to full vision on this Spark integration, I wanted to make sure that we'd gotten far enough along that we had a sustainable Spark cluster and that we were going to be able to persist workload in that platform. And so the boundaries, again, we'd find the relational batch processing was where we saw some of those better ratios of cost, and this is basically you take very large tables and are joining them together in order to build aggregations or things that help become the foundation for insights for data users. And we focused specifically on those things in the short term that were sort of high impact, meaning those things that consume the most resources on the enterprise data warehouse, so that in removing those things, even though the effort was relatively high, because those are some of the most difficult things to convert, it provided us a return. And in fact, for 2017, over a relatively short time frame, we were able to offset the investment we would have otherwise had to make in the enterprise data warehouse, the 20–30% growth, and instead direct that into our Spark platform. So now based on that, I'm going to hand it over to Kim to go a little bit into the next.
Thank you. Oh, wow, a big crowd here today. Wow, this is great. Good afternoon, my name is Kim Curtis, and as Brian mentioned, I lead up the engineering teams for eBay in Seattle. Today, as Brian mentioned, we have been evaluating open source for quite some time with vendor-based solutions. And over that period of time, we've finally gotten to a point where we do see a parity within the two. And that's when we made the decision to start to integrate open source into our data warehouse ecosystem. The first things we looked at is we wanted to evaluate our current ETL infrastructure, or ELT infrastructure, excuse me. And what we wanted to look at is we have 100,000 jobs that run every day at eBay. And it's going to be a huge amount of migration work if we wanted to go out and build this whole new ecosystem. And so what we decided to do is we're going to reuse or try to reuse and extend the components that we had, and that's what we did. The other thing we looked at is we looked at our current architecture. Today, we extract once, we load n number of times, and we transform n number of times. And we wanted to move that to where we extract once, we transform once, and then we load n number of times. And I'll go into a little bit more detail about that. The other thing we wanted to do, as Brian mentioned, is we wanted to optimize our hardware, meaning that we're going to use a combination of very high performance nodes with SSD and also high memory, in combination with lower performance nodes, just big data SKUs with lower memory. And the reason why we did that is that we wanted to optimize the workload, meaning that there's certain workload that we have that is very much more performant when we run it on SSDs versus other workload. And a great example is, as I mentioned, eBay's got a large number of jobs. And we have some jobs that rely on foundational data sets that we have today, many of them. And it didn't make sense to actually have that data be read in every single time. And that's a great example of where we show that, actually have that data and store it on our SSDs. The other thing we did is we actually looked at optimizing the software. We've got thousands and thousands of lines of code. And so what we did is we actually built an in-house tool that took our vendor-based SQL and converted it to Spark SQL to minimize our migration efforts. So before moving to Spark, this is our current architecture. And as you can see here, we extract once, we land it on a file server, we then load that data into several vendor-based solutions, we then extract that data out once again to a file server, and then we merge that into our Hadoop clusters. Now, while this architecture has worked very well for quite some time, it does have a lot of duplication, as you can see. And when you're dealing with the massive amount of jobs that we have at eBay, it's one of those where when you're wanting to make sure data quality, integrity, availability across all these systems, it can become very problematic. As we adopt Spark, this will be our new architecture. And as you can see, it's a much more simplified version. We extract the data once, We land it on our file server. We then upload that data to our Spark cluster. Then we do all the transformations on that cluster, all right? Then we take the resulting data set, and then we land it onto the file server again, and then we merge that resulting data set both to our vendor-based solutions as well as our Hadoop clusters. Now, this simplified architecture obviously is much more straightforward. We also reduce the latency of getting that data to our Hadoop clusters. But what it does introduce is a single point of failure, as you can see with the Spark cluster. And what we're doing today to mitigate that is for more of our crucial workload, batch workload that we have today, we're continuing to run that under vendor-based solutions until we have a DR in place, which is going to be sometime in 2019. Okay. All right, to implement this, as you can imagine, this has not been a small effort. It's been quite a journey for eBay, and we're still working on it. But we've had to have a very tight alignment with our platform team. And the reason for that is we wanted to make sure that when we're building out this cluster, we wanted to make sure that we had a very robust production environment. We wanted to make sure that we had the right access controls, the right permissions, the right queue allocation, the right workload management. Some of these features and functionalities just don't come in the open source world, so we had to build that in ourselves. The other thing we looked at is we wanted to, as Brian mentioned earlier, we focused on our more complex batch workload first, meaning that we have, as I mentioned, thousands and thousands of jobs. And to get the biggest bang for our buck, we actually did the migration for our complex workload first so that we can get a return on our investment more quickly. And then the last thing that we did is that we have a framework in place today. We continue to build and test that. But the other thing that we did is we actually developed a suite of tools to do auto migration work. When you've got 100,000 jobs that are running every day, from a manual migration point, it's going to be way too difficult to do that. And so what eBay did is that we have this set of tools that we built. And the way I like to look at it is that you have your manual work that's going on here with your engineers. You have this set of automation tools that you've built. And as you slowly merge and work towards each other, with hopefully ending up a little bit more on the automation side to minimize the actual manual work that had to happen there too as well. We got our slides a little mixed up, so Brian and I had to switch these out. So, with any migration, you will find that there's always challenges, and we have had our challenges as well. One of the biggest challenges we've had has to do with data validation between the sources. When you have an old flow and its output, trying to compare it to a new flow with its output, and when you have to actually uplift that data and move it to another target to do that comparison, that can be very, very costly. The other thing we found too as well with Spark is that when you find a data quality issue and you're trying to pinpoint in the new version of the code where that is, that can be extremely, extremely challenging. The other thing we ran into as well is even though we built this great suite of automation tools, the one thing that we have found is that we'd also, after having 20 years of a data warehouse, we have a lot of jobs that are non-standard. And so what we've had to do is continue to evolve those suite of tools so that we can ensure that we can, again, meet that goal of actually having more of the automation done like I talked about earlier. And the last thing is that as awesome as open source is, there's a lot of different types of tools and features and functionality that you get in the vendor-based solution that you don't get in the open source world. And we have found for us that due to that gap, we've actually had to go and build different types of tools to address that. For example, job performance monitoring, alerting, how we want to better do our queue allocation, not just at the queue level, but at the job level. So those are just some of the challenges that we've run into at eBay. And now I'm going to hand it back to Brian, and he's going to finish up the presentation. Thank you.
So this is the slide we had to go back to. Because we had them out of order. So we've gone through this cycle, right? We had our investment cycle. We scoped, we designed. Kim talked about the ETL, ELT. We then moved on to delivery, and this is incremental delivery, as Kim mentioned. So in 2017, we meet a goal. In 2018, we have a new goal. In 2019, we'll continue to have goals for the workload that we migrate. But the point I made earlier, if at any point this gets reprioritized, we actually have a currently sustainable system in most cases. But there are a couple opportunities now for us to continue to invest in this platform, in this cycle of opportunity and investment. So Kim had mentioned the DR strategy. Right now, we operate primarily on a single cluster, and if that cluster is unavailable, the workload falls back to executing in the old paradigm. In this case, what we're looking to move towards is a secondary Hercules cluster, not just DR, but a dual active in a different data center. So if we lose a data center, we still have business continuity. It also allows us to potentially balance workloads between locations. So eBay's enterprise data ecosystem actually operates in multiple locations, physical locations and data centers. And there are some advantages to being able to process data in both of those locations, either simultaneously in the event of something that requires not only high availability, but low latency response to things that, at least in the worst case scenario, we can fail over critical workload from one platform to the other. We have continued to evaluate opportunities in cost performance. It's an interesting thing, right? When we talk about cost performance in this context, they're really two sides of the same coin. In a massively parallel architecture, performance is just a factor of investment, right? If I need something to run twice as fast, I'll just buy twice as much hardware. But obviously that carries with it a cost implication. And so when we look at this cost performance optimization, I'm actually surprised, honestly, that we made it as far as we did before we've had to really invest as aggressively as I imagined we were going to have to do in the software tuning. Again, we made some advantages. Kim talked about the two-tier physical architecture we use, the different types of servers, and that bought us quite a bit on the hardware side. But the software tuning, I think we're still relatively nascent in our capabilities in that space, and that's a place that we'll continue to invest once we run out of current capacity. I'm guessing it will become very critical. And then the last thing is feature expansion. Now, this isn't necessarily currently in cycle, but at some point, I think we look at the opportunity to integrate sort of algorithmic processing into the data preparation stuff that happens within the enterprise data warehouse. Right now, a lot of the data gets removed from the enterprise data ecosystem in order for ML to be applied on top of it. And I think this provides us the opportunity to do that sort of implicitly on the platform. And then now the service that we're providing to our customers is sort of modeled data and models that they can apply with, as opposed to them having to do that stuff themselves. And so this is really the end, the middle, the beginning, right? This is just part of this cycle. It's this constant evolution cycle, constantly identifying opportunities, pursuing those opportunities, making investments, and those investments may change the cycle. For example, one of the things we're currently looking at is, so we've got the majority of the enterprise data warehouse sort of relational processing moved over. Now, what are our opportunities in the interactive query space? Maybe that's going to be Spark SQL. Maybe it's a different technology because we need, we get a different open source technology that provides sort of in-memory index storage more quickly and more effectively. But that's basically the end of this. I'm certainly happy to take any questions that anybody has.
Brian, you mentioned about you have the special hardware, if I get it, that is a factor into the total cost ownership calculation. So
sorry, I missed that. I'm having a hard time.
Your first slide, you present the total cost of ownership between vendor and open source, and beside, I think the picture gets closed at 2017. And then you mentioned you project it to be on par to this year and better next year. And one of the factors you mentioned is there's a plan to use specialized hardware. Do I get that right?
Yeah, so the specialized hardware, so basically what we started with when we were sampling these things is we were looking at our general Hadoop SKUs, and our general Hadoop SKUs have a lot of storage but relatively little memory. We knew that memory was likely going to be our resource constraint on this platform, so what we ended up doing is buying some processing nodes that were high memory, rich in memory, and had SSDs for spill. We still manage the data on the cheaper big data SKUs, high storage, but they also come with a little bit of memory. So when we do the final merge, right, the problem still with HDFS is that final merge requires a rewrite of the entire data set. Yeah. But so we execute that final merge still back onto the storage low performance nodes, but the relational processing, the things that's memory intensive, happens in the high performance. Okay. And there still could be some more optimization, right? We might find that we still run out of memory, in which case, hey, we'll go from 384 gigs to 512, or we may in fact find that our bottleneck starts to become network I/O or physical I/O or something.
Hi.
Hey guys, we still have a question session, so if you could be courteous and let our speakers have the floor for their allotted time section. I'm going to move to each person and get them in order, okay?
Okay, I'll go ahead. I think Kim mentioned that while doing the migration, right, you use some third-party tool to do a lot of like vendor-based SQL to Spark SQL. How did the performance for that came out? Like, because the way distributed computing works is different than how the vendor-based relational joins and all that works, so the strategies have to be different. So did the code base migrate as is with the third-party tool, or there were a lot of refactoring that needed to be done?
So it's not a third-party tool. It's an internal tool we built.
Okay,
and yeah, it starts with a relatively simple conversion SQL to SQL. What we find in the vendor solution is we tended to stage data a lot in intermediate sort of temporary tables, if you will. And what we found is one optimization we could add to that was to not do that. Basically, Spark allows, so through the lazy evaluation, that it can make better decisions. We were basically forcing the vendor solution to make a particular decision and how it went through that by instantiating the intermediate data sets. But that was something we were relatively trivially or somewhat easily able to enhance the conversion tool to go ahead and remove that type of things. But more complex things, yeah, I mean, there's always tons of opportunity to continue to optimize. And one of the things we'd look for is cost-based optimization, right? You know, something we're interested in. Adaptive execution is something we're interested in. Anything that's going to remove some of the tuning responsibility from us and put it into the platform.
Thank you.
Thank you for the presentation. That was really interesting. So my question is about the data centers, and it seems that you are using your own, or trying to come up with your own hardware stack right now for your organization. So with what we are hearing about separating the compute from the storage and the optimization that we have it with the providers, have you looked into them and then you rolled out, no, I need to do it myself? What was the reasoning behind it?
Yeah, I mean, so it's interesting. Our first attempt, we kept our existing Hadoop platforms as our data layer, and we did all of the processing on these Spark dedicated nodes, right? So we had Hadoop nodes that sort of did data management. The problem we ran into was honestly a network issue. It was just internal to we had multiple pools that we had to communicate between, and it created a bottleneck. Switching, you know, separating the processing and the storage is something that's sort of implicit in how we've designed it. We don't, you know, we're not talking, I saw a presentation yesterday about the disag. We're not at this point moving the spill, right, the local storage off. We continue to have high performance local storage. And in fact, we believe that represents an advantage for us to continue to have high performance local storage for managing data sets in sort of a caching layer local to where the process is occurring. But yeah, we have separated the sort of physical storage aspect, although right now they exist as part of the same cluster. That's not a requirement, other than through the mystics of network design.
Hi, thank you for the presentation. I think maybe I missed it, but could you speak if we go back to the slide talking about comparing the cost of open source to what you currently have? So in 2017, we talked about it being almost 1 to 2, right? But then it mysteriously equals out and then it goes down in 2019. Can we talk a little bit about what drives that for you guys and why the projected cost of an open source solution seems less to you in 2019 than what you have on a vendor-based system?
Sure. Yeah, I mean, specifically this goes to a projection of our ability to hyper-tune for our specific needs, right? The challenge of a vendor solution is a vendor solution evolves at sort of the rate of evolution of the community as a whole. Unless you represent a massive percentage of that, your optimization opportunities may not be highest on their list. In this case, since we control more of the environment, we feel comfortable that we will be able to make more enhancements in the software space, and then in this case also with additional tuning on the hardware side.
Cool. Thank you.
Hi, Eric from Acorns. I might have missed it, but you outsourced the talent for Spark. Is that correct? For converting from all the ETL jobs to Spark?
Sorry, I didn't
You
get
outsourced the converting from ETL job to Spark. Is that right or no?
No, we're doing that internally.
Oh, okay. So then my question is the people aspect of that is transitions from the old technology to new technology. What was the plan to kind of move forward after everything's done? So has it done previously or just going forward? The old technology, the people side of it, how did you handle that?
why we wanted to leverage our current ETL infrastructure that we have in place today and continue to extend that, because that's the environment that our engineers are familiar with. So when we talk about the ramp-up time from a skill set perspective, it minimized that effort for our engineers. Granted, there is some work that they're still learning as far as Spark itself and how to perform it. And you've actually got 3 engineers right in front of you from eBay that could actually give you more information on that. But that's been one of our biggest challenges is not so much ramping up on the actual code and the development. It's really understanding when you run into a data quality issue, where in the pinpoint in the code where that issue is.
Okay.
Okay.
Thank you.
Sure.
Hi, thank you for the presentation. So the question I had was that generally when you move from a more traditional data warehouse to, let's say, a Spark-based, Hadoop-based solution, a couple of things stand out. One is, how do you maintain, so a vendor-based solution would probably have, data quality management, or your ETL process may have data quality management, which is something you may have to develop when you have a more Spark-based solution. And the second question is, what do you do about master data management? Do you include Spark in that entire master data management process? Or what have you thought about in terms of?
Yeah, so I mean, we have the advantage of it's a pretty mature ecosystem. And so we have a lot of those tools that exist, and not a lot of our tools are dependent upon vendor-specific tools. We have a lot of our own sort of home-built tools where the vendor-based tools integrate. So in this case, it was really a function of adding, for example, the dictionary for the stuff that we were going to manage on the Spark cluster, adding it into our data management infrastructure, right? Our whole metadata repository context. But yeah, I mean, certainly we have a bit of an advantage in the sense that because of the maturity of our environment, we had a lot of solutions in place that it was really just a problem of fitting this new environment in. And since we already have a relatively large Hadoop installation, some of this stuff was relatively trivial.
Okay, so even with Spark, you will have to deal with data lineage, right? As the data goes through transformations.
Yeah, so we have a data lineage tool that actually reads our SQL, and it can read the Spark SQL as well.
And we already have that in place today.
Okay.
Okay. And we'll have to call it there, guys. That's really awesome. Let's give a round of applause, everybody. Thanks.